Hello everyone, myself Manasa Naik, B.Ed first year student of KLE Society College of Education, Ankola. In this video, we shall study about force and pressure. Observe this image. A boy is opening the door and a girl is closing the door. A football player kicks the ball. A person lifts the bucket of water from the well. Are few of the most common things that we perform in our daily life. Then tell me, what do you mean by a force? Force is nothing but a push or pull on an object. In the first picture, we see that a person is standing behind the car. Suppose a man now begins to push a car. That is, he applied a force on it. The car began to move in a direction of applied force. This means that the man has to push the car to make it move. Observe the other three images. Can you decide who is pulling or who is pushing in this case? Both are trying to push each other or pull each other. From this example, we can infer that at least two objects must interact for a force to come into play. Two friends pushing a heavy load in the same direction. Is it easy to move it? Yes, it is easy to move because force applied on an object in the same direction add to one another. Two friends pushing a heavy load in an opposite direction. Does the object move? If it does, then one among them apply a larger force. This means that if the two forces act in an opposite direction on an object, the net force acting on it is the difference between the two forces. Have you ever seen a game of tug of war? In this game, two teams pull at a rope in opposite directions. Members of both the team try to pull the rope in their direction. Sometimes the rope simply does not move because the two teams pull at it with equal force. This means that if two forces act in an opposite direction of an object are equal, the net force acting on it is zero. So we learn that the force can be larger or smaller or equal to each other. The strength of a force is usually expressed by its magnitude. We have to specify the direction in which a force acts. Also, if the direction or the magnitude of the applied force changes, its effect also changes. Push a ball along a level surface. Now the ball starts to move. Push a ball again while it is still moving. Is there any change in its speed? Does it increases or decreases? This suggests that if a force applied on an object in the direction of its motion, the speed of an object increases. Place your palm in front of a moving ball. Remove your palm as soon as the moving ball touches it. Does your palm apply a force on the ball? What happens to the speed of a ball now? Yes, the speed of a ball decreases. This suggests that if a force applied in the direction opposite to the direction of motion, then it results in the decrease in the speed of an object. Now, place a ruler in front of a moving ball. This means that you apply a force on a moving ball. Does the ball continue to move in the same direction after it touches the ruler? No, it changes the direction. This means that a change in either the speed of an object or a direction of motion or both describes the change in the state of a motion. Thus, force may bring change in the state of a motion of an object. An object may be at rest or in motion, both are its state of motion. A rubber band suspended from a nail fixed on a wall, then by pulling its free end, the shape of a nail changes because larger force is applied on it. When you press the sponge ball, there will be a change in the shape of a ball. This means that when you apply a force on an object, there will be a change in the shape of an object. We have studied about a concept of force are due to an interaction. The interaction is of two ways. They are when two bodies in contact with each other and when two bodies are not in contact with each other. The force results when two bodies are in contact with each other are called contact forces. And force results when two bodies are not in contact with each other are called non-contact forces. When you lift a bucket of water, where does the force come from? This force is caused by the action of muscles in our body. The force result due to the action of muscle is known as a muscular force. Animals also make use of a muscular force to carry out their physical activities and other tasks. Animals like bullocks, horse, donkeys and camels are also used to perform various tasks for us. In performing these tasks, they use muscular force. Since muscular force can be applied only when it is in contact with an object, this is called as a contact force. A ball rolling along a ground gradually slows down and finally comes to rest. It is a force of friction between the surface of a ball and the ground that brings the moving ball to rest. The force that opposes the relative motion between the two objects when they are in contact with each other is called the frictional force. The force of friction always opposes the applied force. Since the force of friction arises due to the contact between the surfaces, it is also an example for a contact force. When like poles of the magnets are placed near to each other, make sure that the two magnets do not touch each other. Observe what happens. The two magnets will repel each other. Similarly, when unlike poles of the magnets are placed near to each other, the two magnets attract each other. A magnet can exert a force on another magnet without being in contact with it. The force exerted by a magnet is an example for a non-contact force. Rub one of the straw with a sheet of paper and place it near the another straw. Make sure that the two pieces do not touch each other. A straw is said to have acquired an electrostatic charge after it has been rubbed with a sheet of paper. So the two straws get attracted with each other. Rub the another straw with a sheet of paper and place it near the another rubbed straw. Both the straws acquire electrostatic charges. These straws are an example for a charged body. So there is a repulsion between the two charged straws. So the force exerted by a charged body to another charged body or an uncharged body is called the electrostatic force. The force come into play even when the bodies are not in contact. So electrostatic force is an example for a non-contact force. Leaves and fruits also fall to the ground when they get detached from the plant. Have you ever wondered why it is so? Can this happen without a force acting on it? Which is this force? An object or a thing that falls towards the earth because it pulls them. This force is called the force of gravity or just a gravity. It is an attractive force. The gravity is not a property of earth alone. In fact, every object in the universe, whether small or large, exerts a force on every other object. This force is known as a gravitational force. So, gravitational force is also an example for non-contact forces. Is there any relationship between the pressure and the force? Let us find out. Try to push a nail into a wooden plank by its head. Did you succeed? Try how to push the nail by the pointed end. Could you do it this time? The area of a pointed end of the nail is much smaller than that of its head. Do you get the feeling that the area over which the force is applied plays a role in making this task easier? So, the force acting on a unit area of a surface is called the pressure. Pressure exerted by water at the bottom of the container depends on the height of its column. When a water pipe leaks, you can see the foundation of water coming in all directions. This is because the water exerts the pressure on the wall of the pipes. Similarly, when a balloon has holes, the air escapes in all directions. So this shows that the liquid and the gases exerts the pressure on the walls of the container. On observing this image, we can say that the liquid exerts the equal pressure at the same depth. You know that there is a air all around us. This envelope of air is known as the atmosphere. The atmospheric air extends up to many kilometers above the surface of Earth. The pressure exerted by this air is known as atmospheric pressure. The reason we are not crushed under this force of gravity is that the pressure inside our bodies is also equal to the atmospheric pressure and balances the pressure from outside. Thank you.